6.3 test for parallelograms. So in 6.2 we learned the attributes of a parallelogram, and here we are learning to see if a figure is a parallelogram. So for conditions for a quadrilateral to be a parallelogram, both pairs of opposite sides are parallel. So we have to know that segment AD is parallel to segment BC. And we have to know that AB is parallel to DC. Or we could have both pairs of opposite sides are congruent. So then AD is congruent to BC, and AB is congruent to segment DC. We would have to know that both pairs of opposite angles are congruent. So we have to know that angle A is congruent to angle C, and angle B is congruent to angle D. The diagonals bisect each other, so I have to know that segment DE is congruent to EB, and AE is congruent to EC. Or one pair of opposite sides is both congruent and parallel. So one pair, so if I know that AD is congruent to BC, and the same side, AD, is parallel to BC. So in order for a figure to be a parallelogram, it only has to meet one of these. Okay, so one of them. So below, example 1, determine whether each quadrilateral is guaranteed to be a parallelogram. Here I can see our diagonals are being bisected, so yes, the diagonals bisect each other. Since it meets one of the attributes from above, then it is a parallelogram. For B, no, we need more information. Either both pairs of opposite sides need to be parallel, so this side also needs to be parallel, or I need to know that the one side is parallel is also congruent. I don't have enough information here. For C, 118, 118, 62, 62. So yes, my opposite angles are congruent. Since my opposite angles are congruent, it meets the attribute for it to be a parallelogram, so it is a parallelogram. For D, no, this is not true. One pair of sides needs to be parallel and congruent. So since they're showing us that one side is parallel and a different side is congruent, it is not a parallelogram. This side would have to be congruent to that side because it's parallel and congruent together to meet that last attribute. Example 2, find x and y so that the quadrilateral must be a parallelogram. So this is pretty similar to what we did in 6.2, except here I know that my opposite angles are congruent. Since I know my opposite angles are congruent, I can set them equal to each other. So 5x plus 29 is equal to 7x minus 11. Solving here, subtract 5x over 2x minus 11. So then I have 40 is equal to 2x, and 20 is equal to x. Okay, and then the same thing with my y's, so I can say that 3y plus 15 is equal to 5y minus 9. Solve for y. 15 is equal to 2y minus 9. And then I get 24 is equal to 2y. And 12 is equal to y. And then for this next one, my diagonals are being labeled. I know that's kind of misleading, but the diagonals are being labeled. So here I know that the diagonals bisect each other, making this congruent to that, and then these two segments congruent. So now that I know that, I can go ahead and solve for x and y to find the value that would make them congruent. Okay, so I just solved there very quickly, but I got -6 for x, and I'm going to do y. So set 3y minus 5 equal to 2y plus 8. As always, if you need to, pause the video to catch up. Okay, on the back here, it says determine whether ABCD is a parallelogram. Then it gives us the vertices. I'm going to go ahead and do these in different colors just to help us. So here, method 1, using slopes. So can't forget our slope formula is y2 minus y1 all over x2 minus x1. And for slopes, we have to show that opposite sides are parallel. Okay, so that's what we're looking for. And for two sides to be parallel, they have to have the same slope. Okay, so I'm going to start first for side AD. And I know that A is at -2, 3. D is at -3, 0. Y2, so if I label my points, remember we've done this before, 0 minus 3 all over -3 minus -2. So that is AD. And then I have the opposite side is BC. So B is at 3, 2. C is at 2, -1. since they have the same slope, AD, so then AD is parallel to BC. Okay, but both sides need to be parallel. So now we have to work on AB. A is at -2, 3. B is at 3, 2. If you need to, label your points like I am doing to follow the equation. So that slope is -1/5, and then the opposite side is DC. They are the same, so then segment AB is parallel to segment DC. Okay, so that is it's a lot, definitely. Make sure you know that our slope formula, and for slopes, you are showing that opposite sides are parallel. That is going to be very important for you to know. Method 2, the distance formula. The distance formula, D is equal to x minus x squared plus y minus y squared. And for here, we are showing that opposite sides are congruent. Okay, so I'm going to highlight this to show this is my distance formula, and we have to show that opposite sides are congruent there. Okay, so here for my first side, AB, A is at -2, 3. B is at 3, 2. You can just take this and subtract. So I have -2 minus 3 squared plus 3 minus 2 squared. Simplify the inside of your parentheses first. So -5 squared plus 1 squared, square root of 26. Okay, so that's AB. And then the opposite side, DC, needs to have the same length. So DC, D is at -3, 0. C is at 2, -1. Subtract our x's, doesn't matter what order. Then subtract our y's. So that becomes -5 squared plus 1 squared, which is the square root of 26. Okay, so they match, so we're good. That one side, those two sides are congruent. So now I have to check the other side. My other side here, I'm running out of room. AD. A is at -2, 3. D is at -3, 0. Okay, so that's 1. I'm going to do down here because midpoints isn't as long. So here, B, C, so they both match, so those sides are congruent. Okay, this is a lot. So now for midpoints, I have to show that diagonals bisect each other. Okay, and then remember with midpoint formula, it's x plus x divided by 2, y plus y divided by 2. So here are our important information. So starting off, my one diagonal, AC, A has points at -2, 3. C has points to -1. Then to find the midpoint, we're going to add together our x coordinates and divide by 2. Add together our y coordinates, divide by 2. So the midpoint here is at 0, 1. Okay, so simplifying, -2 plus 2 is 0. 3 plus -1, 2, divided by 2 is 1. And then DB, finding the midpoint. So since they have the same midpoint, the diagonals bisect each other, meaning it is a parallelogram. Okay, so I think we're going to do example 4 in class, just because I'm sure that was a lot, and it'd be good to hear me talk about it in class as well. So I'll do example 4 in class. So that's all.